Hello, everyone. So we will talk about the 2025 AIME problems. So I actually planned doing this like last week even, but I didn't really have time to start. So let's get started with at least now. So the first problem asks sum of the all integer base b, which is larger than 9, for which 17 base b is a divisor of the 97 base b. So like, okay, so we do have a couple of ways. Maybe we approach the first thing, maybe we can change into base 10. So this guy would be like b times 10 to the 0th power, which is, I mean, b to the first power times 1, which is b, and then plus 7 if I just make it base 10. And then same way, it's going to be 9b plus 7. So we are told 9b plus 7 is going to be divisible by b plus 7. So like at this point, you can say this is equal to integer and kind of go with that. But I'll try a little bit differently first. Like since this is going to divide the numerator somehow, for this to be integer, then numerator should have b plus 7 as a factor. So I'm going to take like 9 because b has to be alone as a common factor. So if I take the 9, so I should have b plus 7. And then we have b plus 7 right here at denominator. So like, but this is going to be 9b plus 63, but that's 7. So which is why we need to subtract 56. So we can get actually 7. And we are told this fraction is going to be integer. So if I split this with this guy, so you will get 9 times b plus 7. And then this is over b plus 7. And then minus of 56 over b plus 7. So like, since these guys are the same, so we can cancel that. This is going to be equal to 9 minus of 56 over b plus 7. But how this is going to be helpful? Since we know the result is going to be integer, right? So then this is integer, so this fraction should be gone. So that means 56 should have a divisor. So I mean, b plus 7 should be a divisor of 56. So, and also we know b is larger than 9, so then b plus 7 has to be larger than 16. So when you look at the divisor of 56, we don't have too many divisors. Like b plus 7 could be like, if you divide this by 2, you got 28. If you divide by 4, you got like 14, but 14 doesn't work. So 28 is one divisor, or 56 is another one. And then there is nothing else. We cannot really take the negative version as well because we want b to be a positive integer. So we have only two values for b plus 7. So for that reason, b is going to be like 21 or 49. And if you add these guys, you get some of those b's as 70. And that was the first problem. But I can do this slightly differently instead of doing this fraction approach. So like what we can say, like 9b plus 7 divided by b plus 7. If this result is integer, I'm going to call that integer maybe like c. So if I do cross multiplication, so you get 9b plus 7 equals bc plus 7c. So like we have the bc as a variable, like two different variables as a product, and then b and c is given also linear term. This is kind of a good job for the assignment. So some people call completing a rectangle as well. So let's pull everything one side. So the bc plus 7c minus 9b. I'll leave the 7 on the other side still. And then we will try to complete the rectangle, which is just assignment. So to get that, so this has to be b and c separately. To get 7c, I need to multiply this by 7. So 7 must be here. And to get negative 9b, so we should have this. And then this was 7. But when you expand this, you got 7 and negative 9 is also added other term that was not here. So that is just basically added to the left side as negative 63. We cannot play favorites, so we should add that as well on the other side. So now we have the b plus 7 and then c minus 9, which is going to be 56 with minus sign. So like now we do have the same story because this is going to be integer. This is also integer, and you look for the divisor of negative 56. So as you did right here, so you will get those two same divisor, which is going to give us 70 as well. Either way it works, but that was the first problem. So the second question is, we have an interesting figure. And the problem says, like, we do have, let me actually highlight some of the things. AB, AD, EB are lying on side AB, which is right here. And then these guys also on the other side. So AD is 4, so let's write that. And then DE is 16. So this piece is 16. Okay. And then EB is 8. So EB is 8. So that should be 8. And then DE, like 16. And AF is 13. So this is 13. FG is 52. So this guy, FG, is 52. GC is 26. So this is 26. And M is the reflection of D through F. So M is right here. So reflection of D through F, meaning that DF and FM is equal. And then NB reflection of the G through E. So basically the same sort of right here as well. And then quadrilateral DEGF. So DEGF, so this middle guy, is given as 288. And we're going to find the AF and BCEM. So AF. And then we have N right here, and then B, C. Okay, basically shaded region. Okay, so like since we are told some reflection, so maybe we should use that for sure. So the first thing I'll try, we have a lot of numbers are given, so maybe we can start using that first. Like this was 4, this was 13, and now we know DE was 16, and then FG kind of corresponds is 52. When you take the ratio, you got like 4 over 13, which is the same as this one. And if you take the ratio of 8 to 26, that's also the same. So meaning that all these like lines, so DM and then like GN and BC are parallel. So if you remember, like we call that like triangle proportionality. So we do have parallel lines dividing the triangle into proportional, basically. That's one way we can say they are parallel. But now how do we use that? Like we do have a lot of ratio, which means, I mean, a lot of like parallel lines, which means a lot of similar triangles. But let's try to see if we can get something. First, we do know the ratio AD to AE is like 4 over 20. So I can write 4 over 20. and that is 1 over 5. So what is that telling us? Like if I know the df something, then eg will be 5 times as much because of the ratio. And also, like, let's actually write that. So let's call df is going to be x, and that will be 5x. And that's same as NE is also 5x because they were reflected, and then this is going to be x as well. So like the triangle right here, if I call this is t, dft, and then E and T is also similar because these two parallel, so these angles are equal, and then these are alternate interior, and the ratio is x to 5x, so which means like if I know this is something, then this is going to be 5x. So like I'll call this is, let's say, y, and then that will be 5y. Okay, and that will be like 6y in total for the E, so maybe we can just make it as well for the other guys. But we know we don't really need actual value, but maybe it's useful anyway. So maybe I'll just use the ratio, so like area relation. So since this base is y, and then this is like a 5y, maybe we can make a triangle that has the same height. So if I go with this, so like we do have a triangle. I'm going to call this is A for the DFT. So that means this region has to be 5A. And because the point F is the common vertex, if you drop delta from F to like AB, that will be the same height for this triangle and this guy. So that's why base ratio will be area ratio. And we know that this part was like 16, right? So then, and then the F is common vertex for the triangle ADF as well. And the ratio of the base is 4 over 16. So 4 over like 16, which is 1 over 4. And the area ratio will be 1/4 as well. And then we know this is 6A if you take the 1/4, so that should be 1.5A for this region. And if this is 1.5, this is also 1.5. Okay, so like we are kind of getting something. And now we know that this was like of 6A, so meaning that this region also 6A. So that is 6A. And we can divide that 6A into the ratios as well. Maybe I should do it as well, but since we know the 1 to 5 ratio is also there, so like what I'm saying that this is x, this is 5x, so that means this to this 1 to 5 as well. So meaning that this is A and this is 5A. Okay, so we are almost getting a lot of things already, right? So like what else do we have? Since we know this is 1 and then this is 5 in terms of ratio, so then if this is 5, so that means this is 25A. So that is also a good one. And since we know that this region right here, like I'll say this guy right here should be like, since we know this is 1, this is 5 as a ratio, this is 5, that means this is 25 as well in terms of that. And the rest is just kind of fall apart. So like the region right here, this region right here is actually same as this one, and the region right here is going to be same as this one. So if you're not convinced, because like this is the base is 5x and this is the base is 5x, and the height between BC and G is the same, so which is why we can take this guy and put it here, take this guy, put it here, and similarly this guy here and this guy right here. Basically, they're asking area of the ABC, and if I find ABC, that's basically what we are looking. Okay, so like what we were given was the ratio, right? So if I want to take I can find all of these, but kind of if you really want to finish these regions, because only these three are left in terms of writing A, so we can get the answer immediately. But I'll try to use the similarity ratio as well. So like first, the ratio of AD over AE, like is 4 over 20, right? So we already had this right there. So this was 1 over 5. So the ratio is 1 to 5. So the area ratio will be 1 to 25. So that means if I take the area of ADF is like ADF is going to be, let's say, S, then the remaining DEFG E, so will be 24. So that means this guy will be 24S, is going to be 288. And this is like 144 times 2. So this is 12 times 2. So that means if I take this, I'll divide by 24. So that should give us just 12, which means this region right here will be S, which is 12. But we need the entire region. The ratio is 4 over. So this was like 16. When you add it, you got 20 plus 8, 28. So that will be like 1 over 7. But that's the ratio. But the area ratio should be 1 over 49. And since we know the S was 12, so that should be 12 over entire region, ABC. Okay, and then if I take the 50 times 12, which is going to be like, let's see, actually I'm going to write this one. So 12 times 50, and then, but this is not 50 times, this is one lower number of times, which is minus 12. So that will be 600 minus 12, which is 588. So that is our answer. So there is like some other ways, but I think using the area ratio with the base relation, and then maybe including similarity was way to go. Anyway, so that was number 2. Number 3, so we have 9 members of the baseball team went to ice cream after their games. Each player had a single scoop cone of chocolate, vanilla, or strawberry, or ice cream. At least one player chose each flavor, and the number of players who chose chocolate was greater than the number of players who chose vanilla, and which was greater than the number of players who chose strawberry. Okay, so I'm going to call the number of people who chose the chocolate is like C, and then we are told this is larger than the number of people who chose vanilla, which is V. That should be larger than S, so CVS. Okay, and then we also we're given at least one player chose each flavor, okay, and which was greater than number of, okay, and is the number of different assignments of the flavors to be players that meet condition. Like since we are told at least one, so I'm gonna go with having this the S should be at least one, and since we have 9 people, so I will say S plus V plus C should be 9, since 9 is not the big number, we can actually go with the cases. So this could be at least 1, and then this might be 2, which is 3. So this must be 9 to get the 9. And if this is 1, and then this is 3, that's 4. So that will be 5. I cannot do 1, 4, 4 because they should be at least larger. And then I can have 2 right here, and then 3 right here, and then this is 4. So it looks like this is the 3 different distribution we can have. So the first one, we have 9 people who are going to choose chocolate, but what are those, like, I mean, 6 people will choose chocolate, but what are those 6 people? So which is basically, we need to determine those 6 people out of 9 people. So 9 choose 6. As soon as we determine those 6 individuals, there are 3 people left. 2 people like should choose vanilla, which is 3 choose 2. And then the last will be determined. So I can just say 1 choose 1. That's just 1. And the second case, 5 people will choose out of 9. So for chocolate, and then the remaining 4 people, so 3 choose, I mean, out of 3 will choose the vanilla, and the last chose the strawberry. And the 9 choose 4, and then 5 choose 3. So like you can include the last one, but just one anyway. So like 9 choose 6 is the same as 9 choose 3. So that's going to be 9 times 8 times 7 over 3 times 2, which you should probably do this in your head anyway, but I'll go with this one. So this is going to be 3 times 4 times 7. I'm kind of lazy to multiply. And then this is going to be 3. Then 9 choose 5 is going to be the same as 9 choose 4. So 9 times 8 times 7 times 6 over 4 times 3 times 2. So these will cancel. This will cancel. So you got 9 times 7 times 2. So 9 times 7 times 2. And then 4 choose 3 is just 4. And the last one, 9 choose 4 is the same as this one. So that was equal to 9 times 7 times 2. 5 choose 3 is just 10. So I'm going to leave as 10. So the rest just multiply and adding. So if you just do this, you will get 2016. And then we just like to divide this by 1,000 and then to get the remainder. So that looks like 16 is our answer. So that was our third problem. So let's see the next one. So number 4, find the number of ordered pairs xy where both of these are integer between -100 and +100 inclusive, such that this is equal to 0. Like the first thing I actually think, oh, maybe we can try factoring because we are trying to find the integer solution. So when you have integer solution, it is good to try factoring. And sometimes it may not be kind of easier to see those factors. I'll try something else as well if that needed. So like since we know this is like 12, maybe I can go with 6 and 2 or 4, 3. So 6 and 2 kind of too far apart. So I'm going to go with 4x first and then 3x. And I like to combine the product to get middle term as minus xy. So maybe I should multiply 4 by 2 to get 8. 3 by 3, that will be 9. So the difference will be 1. That looks good. And then 6 does also work. So I'm going to go with this is 3. And then this is like 2y. To make the middle guy negative, so 9 should be negative. So either I think this will be negative and this will be positive. And let's double check if this is actually working. So that's 12x squared, and then that's 8, and then -9. That's good. And then when you multiply, you get that as well. Okay, so from this one, the 4x equals 3x, or 3x is equal to -2y. Like you can write a fraction, but I don't want to do that because I like to deal with integers. So the first thing that we can see, like we can get 0, 0 for sure for both of these, but let's keep that in mind. And then this might be 3 and this might be 4 as our first integers, positive integers. But every time you increase x by 1, you are multiplying this by 4, which means the left side will increase by 4. To balance that, x needs to be increased by, I mean, this was y actually. So this is y. So then if I choose this is 3, then this must be 4. And if I need to increase this by like maybe another 3, which is going to be 6, so that will give us 24. So that should be increased by 4. So this coefficient will affect the change right here. This coefficient will affect the change right here. And if you keep doing this, you get 9 and then 12. And you can list if you want to more, but we want to end up getting 100 or -100. So if I want to go, since this is getting bigger than this guy, so we just need to stop when this is getting close to 100 or 100. So since this is like 96 and 100 is available, and you can kind of list those, or you can really find the corresponding page just to feel kind of satisfied. But from this one, so we have 4, 8, 12, all the way to the 100. So it looks like we have like 25 pairs right here. But if you do include the negative version as well, that's going to be 50. But at the beginning, I said 0, 0 is also good. So which means that will be 51. So that's just 2 times 25. And then plus the 0, 0 pair, so which is 51. And for the second case, I can have this is going to be -2. And then this is going to be 3. So if I choose this like maybe 4, that will make 12, so this will be 6. So let's see the same story. Like this is coefficient 3, this is 2, and then this guy will increase by 3. I mean, change by 3 in absolute value, and then it's going to change by 2, which does work. And you can continue in this like 6 and 9. You can double check, which is actually correct. And this is getting bigger than this guy, so but these are minus. So you want to get at most something that is like close to 100. So that might be like 99. So that will be like 3 through 99. So if you divide by all these 3, that's 31 numbers. And if you swap those with the negative, so you will get like actually 33 numbers. Times 2, which is 66. We don't include 0, 0 because that was included right here. So the answer should be like 51 plus 66, so which is 117. So that was number 4. So I'll continue with the others soon. So let's pause right here. I'll see you next week.